Hello, welcome to another platform engineering video. Today we're going to learn how to set up encryption on Linux. I am joined by senior software engineer Denis Lobanov, who is going to help us answer some security questions as well. Hello, Denis. How are you?
Hi, I'm good. Thank you. Yourself?
Good, thanks. Thanks for your help today. Do you want to introduce yourself to the audience, please?
Sure. So as you said, software engineer, currently at UW, but in sort of my career thus far, I have also done some DevOps stuff and even probably touching on sysadmin, including setting up sort of on-premises clusters for, well, admittedly small companies. So I've kind of went from very low-level Linux to fairly high level.
Okay. What do you think about encryption in personal computers and servers? Do you think it's important?
I think it's mandatory, to be honest. So with personal computers, maybe you can make an argument for your desktop to not have it, just because it's something that doesn't leave your house, at least encryption at rest. However, encryption in transit, I think is frankly mandatory for everything. Encryption at rest in a data center for any sort of service is pretty much mandatory as well. I would say, and frankly, from my own laptops or anything that, even my phone that I take out with me, I always make sure data there is encrypted.
Okay. I'm sure, Denis, you have seen in the news articles about data backed up in cloud services and then being leaked, and also customer-sensitive information made publicly available for everyone to see. What's your thoughts on that?
So, I mean, there's not all of these cases are stem from the same thing. So, for example, if you're storing something in S3 that maybe you shouldn't be, or at least storing it there without particularly good security around the data, this could be partly in terms of authentication, because who has access to that bucket, essentially? Some of it, so I'm actually thinking back at this point to a very old case where there's been forgotten disks and forgotten laptops on trains that have left a lot of people's data exposed. This stuff, in part, this is a case for data encryption at rest. While some of it is the necessity for not just encryption, but also authentication. The two often go hand in hand, but are separate and important to consider.
Okay. I have a hard disk here. I'm sure people know what it looks like. This is an SSD one. So if your data are not encrypted on the hard disk, anyone who gets their hands on it can see your photos, your emails, your personal information. And it's one of the ways that you can get your identity stolen. And that's very serious and bad. So Denis, can you help us learn how we can set up encryption on Linux? Let's say that we have a laptop that's running Arch. What is a good layout to use?
Sure. I'll prefix this by saying this doesn't have to be Arch.
Okay.
I know you're mentioning this because it is a system that's it's one of the ones I use. However, this will apply to, since I'll speak in terms of Linux, this will apply to any Linux distribution. With BSD, it's not too far, to be honest, to jump from this to BSD, though there are some differences. So the first thing, if you're talking about encrypting your hard drive, that you're going to come across is whether or not you want to use block or file system encryption. There are pros and cons to both. But before we go, well, I guess I'll try and explain sort of roughly the differences between the two. Now, in terms of block encryption, the name comes from the fact that the kernel sees drives as a block. And this is an abstraction to a large extent of how a hard drive actually is. Part of the reason is because you have things like SSDs that you've just shown, but also things like old school hard drives. And an SSD is storing its data as a grid array. So in terms of the data lines, you might have addresses going one way and then the block size going the other way. It will depend a lot on terms of the SSD, but this is why you'll have optimum block sizes if you're ever going very low level in terms of configuration. There are certain, or even if you're just doing DD for your Linux image, you can optimize it by setting a block size. So for SSDs, maybe like 248 bytes. It varies between really the technology used. Hard drives, on the other hand, are a spinning platter. So you're going to have, in old school terminology, you'll have cylinders, but that's kind of like the track, except it's not a spiral track on a vinyl. And then you have sectors on that track. So the block sizes are different. But the block sizes are ultimately an abstraction that Linux uses to represent how it's storing data. So if we draw a very bad representation of one, the kernel might see your drive as kind of, let's say it's linear addressing, right? So we have addresses going this way. And the size of a block is kind of this vertical space here. So what that is arbitrary. Now, on top of this block, you might do things like partitioning. And then ultimately, let's say this represents a partition, you're going to set up a file system. File system is going to give you files and directory representation. However, so we can have like a dir, and we can have here a file. Now this file is going to be stored as multiple blocks that will be, spaced in some way around the disk, depending on the file system that you use. And these will all belong to this one file, if you accept my terrible drawings. So here is kind of when we can start talking about the difference between what is file system encryption, or like file system level encryption, versus block storage encryption. Now, in terms of block storage, we can have, again, if we're talking Linux, traditionally something like dm-crypt. The point of dm-crypt is that it only works on those blocks of data, which is a chunk of data that you are sending. So it knows nothing about your file system. It knows nothing about the way that the file system wants to structure the data on disk, or even about your partitions. You should apply either to the, you apply either to the whole disk or a partition. So the way it works is that you will put something like dm-crypt, and let's say this is your file system. This is your encryption layer, traditional encrypt, and this is your block device, so kind of device driver. Now your file system will want to write a block of data, and it's going to use this encrypted device that represents a sort of block device. This will in turn write that exact block of data, but now in an encrypted form, and it's going to be around other pseudo-random noise on that disk. So theoretically indistinguishable from all of this other junk, whilst the unencrypted representation, which is right now only virtual, and if you didn't have the encryption layer, you'd only have this, you could tell whether it's data and whether it's old data that hasn't been erased, as in hasn't been overwritten, or just unused disk. And this is where actually we can start talking about the differences between file system and block layer encryption. For file system, you'll be encrypting on the API, on the level of the file system. So you'll say, I want to encrypt this one file, and the data that constitutes that file, all those blocks are encrypted. Or maybe you'll say, I want to encrypt this directory. The directory is still visible on disk. So if an attacker gets your disk, they can say, oh, you have a directory there. It's going to have some flags set that say that it's encrypted, and they're going to be like, something interesting is in this directory. Or if you have just one file that's encrypted, they're going to say, well, what's in this one file? It's the most interesting thing, isn't it? So they know exactly what to look at. Whilst if you do something like block layer encryption, everything is encrypted. You don't know. And if your partitioning is later, which I'll talk about in a second, then you don't even know what's on that disk in terms of partition layout. So pros and cons.
It's preferred to have the entire disk encrypted, so they don't know exactly where to focus the effort.
Certainly, I would say so. The advantage of file system level is the fact that you can do it after you've installed your system. For block layer, but for fresh install, I would suggest you do it on a block layer. So we can put something like dm-crypt, then you put your something like LVM on top of that, and then you can put your partitions on top of LVM.
What does LVM do?
So LVM is Linux Logical Volume Manager. It essentially allows you to create virtual partitions, or rather than partitioning on the layer of a disk where you write the boundaries on the disk itself, you are partitioning after the fact. This allows you to do things like snapshotting, changing the partition sizes, resizing. You can change partition sizes on a traditional disk, but things like snapshotting are a bit more difficult. So the reason you do this way is simply because you can then encrypt in bulk the whole drive. Afterwards, you put in your partitions. The advantage here being that theoretically, if you say wipe your whole drive, so you put encryption first, you just put loads of random data to fill up the whole drive. Then you put in your main encryption scheme, LVM on top of that to partition it. Your whole drive, it doesn't matter what data you write, all of it is pseudo-random noise. So you don't know whether which block is being written versus which block has just been filled with just noise, because that's how you've wiped it. So essentially it gives it a very uniform look. You could, to be honest, get away with not even partitioning your drive, though if it's a RAID array, you might want to still. That's on the device level. Whilst on LVM, you will still have your partitions. So at this point, we might as well talk a little bit. There's two things I want to bring up. First of all is if this is dm-crypt, you might want to use LUKS on top of that, just as a way to manage your keys. And let's talk a little bit about partition schemes. So here's one I drew earlier. So if this is still a hard drive and it's still the block layer representation in exactly the same way, you can have something like LUKS running here. The reason for LUKS is that something like dm-crypt is essentially symmetric encryption. You give it a good, strong master password, and that's what it will encrypt with. If you give it a weak master password, well, you have a weak encryption scheme. The problem of using a strong master password is now you have to remember it, and somehow you're probably going to have to enter it when you turn your computer on. On top of that, once you've encrypted it with that master password, you can't change this unless you are going to move all your data to another disk, wipe this disk, re-encrypt it with a new master password, move your data back. That's basically a reinstall. So you can put something like LUKS on top. LUKS will go in as a header. So if someone's looking at the raw data on the disk, they will know that you have encryption because they will see the LUKS header. And this will contain an encrypted master password that's used for dm-crypt. And it will then give you key management of, say, having your own password that you use, maybe a second password, or let you swap around passwords if one has been leaked, and maybe just using, I don't know, a USB as the thing to open a drive. Useful if you want to chain multiple drives. This is something I do on my Chromebook, for example. So that I don't want to put in two passwords. I put in one password to decrypt the main drive. That then has a key that's used to decrypt the SD card. That's my home directory. Just for convenience. So on top of that, you can see I've kind of, this is the header. The next free space here, you'll put LVM. This is going to manage your partitions. And then somewhere like dev mapper, you will, instead of dev SDA, you'll have things like dev mapper and then the name of your volume group and your partition. So you can have as many partitions as you want.
Do you have a recommended partition scheme that people should use for their hard drives?
Well, yes and no. I think it's there's a certain bare minimum I would suggest for everyone to consider. There are advantages to not bothering, I guess, mainly simplicity. But if you are going after, say, performance or are really looking into this, I would suggest you analyze a little bit in terms of your particular distribution and your usage needs for the sort of partition scheme that you want, because there are advantages and disadvantages to how far you go. So I've written out a couple. This is, I mean, the first concept is the fact that in Linux, everything's represented in terms of files and folders. The old joke, in Linux, everything's a file, in Linux, everything's a folder directory. So you have, I guess I would recommend, as a bare minimum, you'll probably want a different partition for boot. This is on a few reasons, partly technological if you're looking in terms of UEFI, but also in terms of convenience if we're talking about encryption. You can do encrypted boot partitions. It just gets a little bit more difficult because you will have to ultimately have something, well, decrypted before it can be booted. So maybe your bootloader is going to have to live separately outside of the boot partition, which is chaining your boot partitions, or even you'll have to have a boot partition on a USB key, but then it's probably not encrypted. Next, root, you'll need a root partition regardless. I tend to also go with a home partition, just because the data that I have in terms of root and data that I have on my home directory are different in terms of their size, in terms of the frequency of writes. So the nature of their usage tends to be different. Depending on the system, for my example, my desktop, I'll have a pretty sizable RAID array looking for home, which is backed by an SSD cache, but it's mostly looking in terms of capacity and maybe continuous I/O, whilst something like root is on an SSD RAID, because we're talking about application loading, we don't, and there's a little bit less, well, there's much less space. If it's a laptop, you might want to consider having an actual partition on the hard drive, or even LVM for your swap. So you can do things like hibernate. If you're doing desktop, you can get away with just files, because this will let you potentially allocate and remove additional swap files as your swap usage changes. This is something that OS X does. I do recommend on any Linux system that you have swap regardless for good memory management. Then, depending on your distribution and your usage, you might have things like var and user. These directories can be mounted on their own partitions as well. Some distributions tend to put a lot of small files in var. I know Arch certainly does, especially in terms of like caches. For example, your package cache. My Gentoo installation will also have all the source state there, and I'm doing well. It's a little bit different, depends on how you set up Gentoo. But for me, I also have pretty heavy thrashing with var. So I have that on a separate partition just so it has every file, essentially, so there's a different file system, and every file system, you can tune them to cope a little bit better with the type of usage that you're going to have for a given directory.
I think there was a final one, user. Did you talk about that?
Yes. So user, this is traditionally, well, it's going to be your libraries, your applications. There are some advantages in terms of keeping this. I might be a little bit more tempted on, say, server install. I don't really do this on my own personal systems. There's, to be honest, anything in the Linux tree, you can mount as a separate partition. And you can, if you use an LVM. The reason you might want to have something like user as a separate partition is if you use an LVM to then do snapshotting, for example. Potentially, though, you could also just do it with root, at which point you have snapshots. If you're doing an upgrade, you snapshot your system beforehand, you do your upgrade. If everything goes wrong, you have a potential to roll back, for example. Or you can try and fix your system. It depends, obviously, on what you prefer and how bad things get.
Okay, you touched a little bit on performance, and I remember reading an article written from Cloudflare about how they do encryption at scale, and they went very deep at the source code in Linux kernel, and they found some operations that were needed 20 years ago, but not today, and it was just slowing down the process. So they created a patch, and they have been running it in production for a while now, and it's pretty fast for them. Do we need any special hardware to run dm-crypt? How does it work?
Right, so in terms of special hardware, no, I don't think you can run dm-crypt on anything. As I said, I'm running it on a Chromebook. That's an old Chromebook. It's not a particularly performant machine. There's advantageous configurations. So, for example, you might want to consider the sort of cipher that you're using and the hashing algorithm that it itself uses. Certain CPUs and CPU architectures will have hardware acceleration for these. If you have hardware acceleration, then using the type of hashing algorithm that matches that could give you, well, it will give you significant performance gains, since that is offloaded to an ASIC rather than having your CPU do the computation. This, as long as that encryption is current, and I'm guessing anyone that's running more or less recent hardware it is, then it's still, you're going to have security and you won't have performance trade-offs.
Okay, I would like to ask you about terminology that we hear a lot. What does in-transit and at-rest encryption mean? What is the differences between those two?
Right, so the fundamental difference between these two is whether or not the information that's going over the wire, so for example, information that's been over the wire is another one of these terms, of course, that's been transmitted over the internet, the fundamental packets that are leaving your machine and going out to another, or vice versa, going from another server to your machine, if these are encrypted whilst they're passing through the entire sort of architecture of the internet. This is in transit. Classic examples of this are TLS that's used with HTTP. So HTTPS, the classic scheme when you're going to your bank, for example, presumably you should see that as HTTPS because you don't want any information that you use to authenticate with the bank to be exposed and then for someone else to get access. Encryption at rest is specifically talking about whether or not the data, when it's stored in terms of non-volatile media, your hard drive, whether or not that is stored in an encrypted way. This is also necessary, as we've already talked about, for things like on your devices and on servers. They are two different things, but they do complement each other, and ideally they should be both if we're talking about production deployments of distributed, well, of any system, really.
Okay, that's cool. I think that distinction actually shows us that they are very different things, and they are not to be confused. What are some common encryption algorithms used today?
Right. So it will depend a little bit in terms of the use case that we're talking about. If we're going to carry on with the theme of where we have been now in terms of encryption at rest and in terms of hard drives, then a common cipher, for example, to use for, say, encrypting drive for dm-crypt, I would straight up go with something like AES XTS, and that's going to use SHA-2, well, SHA-256 probably cipher underneath. Sorry, hash. Advantages there being that these class of hashes tend to be hardware accelerated, whilst at the same time it still has enough security that it's that is considered, well, strong. Though actually I think it's SHA-512 and then it gets split to 256.
Okay, circling back to what you said earlier about having keys to decrypt the data, what is the right way of keeping them secure and encrypted themselves as well?
So in terms of managing the keys, this will depend to a great extent in terms of the application for what those keys are securing, and in terms of who holds them. So if it's you as an individual, you will be using things like maybe password manager so that you're not reusing keys, and you can have strong passwords really for different sites. If we're talking about securing information that's used for, let's say, certificates or secrets that are used in a distributed application somewhere in the cloud, you might have some sort of vault deployment. And then this, you'll be looking for something that allows you slightly more broader control in terms of groups of applications that might have access to a certain set of secrets. If we're talking, these secrets could be just certificates that are used to possibly encrypt or even authenticate these applications between each other, just within a distributed deployment, as well as if you have, say, a terminating sort of HTTP proxy. So how you would manage these deployments, maybe you have something instead encrypted in your whatever you use to manage a cluster. Maybe you have your Ansible or a Tower deployment, and you'll have a completely different set of secrets and how you manage them. So we're also talking in terms of how you manage sharing those secrets amongst a team of, say, engineers who are managing this architecture, because they'll need their own set of keys to then have root access to things.
Does it all come down to having the master password leaked? For example, if someone gets their hands on a master password, in theory, they can see all the other passwords and then gain access to all the other systems.
It doesn't have to. So if we're talking about in development and these production systems, you might have, or like more enterprise solutions, you might have certain groups. So a master password here, you might not, well, I guess you could have a master password for everything, and if that's leaked, then yeah, if someone then has the master password and gets access to that data, yes, the keys to the kingdom have been lost, and all hope is lost equally. However, if you have specific security groups, you could have, for example, just a subset of data encrypted and only accessible with a given key is only going to be able to decrypt part of a larger encrypted data set.
What are some password managers that you have used?
So between sort of work life and personal life, a number of the common brands of the shelf stuff like 1Password and LastPassword, as well as a couple of open source sort of things such as Pass, as in, I think its full name is something like Unix Pass or Unix Pass or something, but there's a couple of other rewrites like GoPass, which is essentially using the same system that relies on GPG underneath.
I think that's the one that I'm using as well, and it has this useful subcommand that you can generate a strong password and it automatically inserts it. You can have it in version control and keep it in sync between your different computers. So it's really convenient. It has a few extra clicks, but it does the job in the end. It would be interesting to see what other password managers people use. So please leave a comment below and let us know. One other question I have is, how do cloud providers solve the encryption problem at scale?
Right, so here it will depend a little bit on if we're talking about encrypting at rest or encrypted in transit. As we've sort of earlier said, they are two different problems and require two different approaches to solving. So encrypting data in transit is the one that is often talked about and is kind of like the more in your face, I guess. So a typical approach that would have been used for quite a while is a terminating SSL or TLS proxy. The idea is that you have, let's say you have a cloud deployment, and the specific services within your distributed deployment themselves will not necessarily, or in these, the classic scenario, they don't have encryption between them. The data there is transmitted in the open in plain text. However, before it ends up going over the wider internet, so this is maybe within a specific sort of LAN of the data center, then before going out to the wider internet, it will pass through a proxy, which will add encryption. This has some advantages in terms of, if we're talking about scale, you have multiple services providing ultimately the same sort of business function in order to have reliability and failover if any one particular physical machine dies. This way you can have a centrally managed set of TLS certs that will provide both authentication in terms of authenticity, this is the website I'm visiting, but also encryption. Lately, there has been more move towards encryption between those individual services too. This is more a case of multi-data center distributions, multi-data center companies that will deploy in multiple clouds. The famous example being things like Google, where they have many data centers around the world, and NSA was compromising their own private links between those data centers.
Okay, didn't know that. That was very useful, Denis. Thank you so much. Where can people find you online if they want to have a chat with you?
Platform engineering Slack. Though for the most part, that's I don't have too much of an online presence. I found a far too comfortable rock to live under.
Okay. I hope you found this video helpful. Don't forget to like, subscribe, and leave a comment below. Thank you. See you next time.